Good morning, good afternoon, and good evening, ladies and gentlemen. This is Vincent Tan speaking. This time, I'm going to share you how to adjust the function setting on this condensing unit. We call it Unix. Meanwhile, I also provide the correct subtitle just for your better understanding. First of all, how to adjust the capacity. Here is the picture of the auto unit PCB of Unix 18. And here is the disk switch. The first step is for the capacity setting. Either it is 2 to 3 ton or 4 to 5 ton. As Toso only provides 3 or 5 ton, so here is the default. And the purpose why we need to set this is we can reduce the inventory cost and easier for the contractor to order the unit. And also how to identify it is 3 ton or 5 ton because they should just share the same PCB is by this jumper, and there is a jumper cat here. And this is for the Unix 18. So for the Unix 16, we just here is the auto unit PCB photo. We just use this jumper cat, the blue one, to identify the different capacity. In summarize, for the Unix 16, all the models have different jumper cap. For Unix 18, the dip switch, this one is upside down, also makes the installer a little bit complicated to verify the dip switch location, right? And I'd like to emphasize that here, this Y level, which is this one, if it is close to this on side, that means it is on. So for our 3 turn and 5 turn default setting, this first dip, this Y level is at the on side. As for the number 2 to number 4, the default setting is in the opposite direction. Also means this is at the off side. The second tip is to set how to defrost. The benchmark is standard, so you are allowed to adjust to be strong or enhanced defrost. You can just consider it as a early enter and exit later, then we can defrost more clearly. And how to achieve it? It is that, for example, in the defrost judgment, which is continuously hitting from the original, let's say 45 to 40 minutes, then we will judge the temperature, which is from the defrost sensor. If we miss the requirement, we will allow you to enter the defrost. And also the judgment, we can adjust from the original, for example, -3 degrees Celsius to 0. And this can make it too easier to enter the defrost. And also during the defrost, we will higher the compressor frequency to ensure it can defrost more clearly. And meanwhile, also we adjust the defrost period from the original, let's say 10 minutes to 30 minutes. And for this one, according to your situation, which if you find the defrost is not there completely, then you can adjust to be this enhanced defrost. And if it is can defrost more clearly, it will much better for the next heating cycle. For number 3 and number 4 tip is to set how to do the regular operating. Although we have this statement here, but I think it is not that easy for understand. So I just draw a diagram for your better understanding. And from this diagram, we will have the room temperature, and here is the time. For example, we will do the heating. So here is the set point. And also all these 4 conditions just start from here. So for the standard one, the benchmark default setting, we will have this one, which is how long it costs the room to reach the target. And after that, how it maintain the stability, not that fluctuation, right? And for the number 2, it is strong. Also, you can consider it as a fast cooling and fast heating. At this time, we will higher the compressor frequency to earlier to achieve the target, which just like this. And also, you can find that compare with the Number one, the time is less, but the configuration is a little bit more. For number three, we focus on the energy saving. For this one, we can reach the target not that fast, but the fluctuation, we just focus on that, just like this. Longer time, but the fluctuation is not that much. And number four is only for the Unix 16. For this one, we just make a balance between the fast cooling and the energy saving, just like this. And this is only for this one, and this cost time is just also between T1 and T3. So we will have the sequence comparison, which is this. Just follow this one, and also same for the room temperature fluctuation, which is the stability, will become this. So on site, you can ask your customer which it is focused, either on the energy saving or fast cooling and heating. Just depends on this to adjust this one. Either on the Unix 18 or Unix 16, the Auto UniPCB, there is a LED here. This one is just to display the operating status or the parameter, and also even the error code. And for the function setting, for the Unix 18, you can find these buttons here. This is according to this SW1, 2, 3 to set different functions. Here we offer you the force defrost, which is manually defrost, and refrigerant recover, which is to collect the refrigerant of the pipeline and the air handler. And force operation mode, this is just for the test run. Not once applied, it will ignore the signal from the 24-volt input. As for Unix 16, there's no buttons here. All the function settings should set from the portable debugger, this one. Refrigerant recovery function. For this one, you can follow these steps to enter or to apply the refrigerant recovery. And also once you enter, the system will display the signal for you when to close the liquid valve and when to close the gas valve. Just follow the signals from the LED, then you can recover the refrigerant. As for the force operating mode, that is only for the test run. And also, just like what I said, you will just ignore the signal from the 24-volt input. And also just follow these steps to apply either for cooling mode or for heating mode. That's all for this sharing. If you still have any other question or suggestion, feel free to send me to my email address. Hasta la próxima. それではまた今度。